In this video, I will explain the flow behavior in open channel using HEC-RAS. I will analyze flow condition focusing on how water moves through a prismatic rectangular channel with a constant discharge, slope and depth. I will define key hydraulic parameters including Froude number, water surface profile and energy grade line and channel slope while explaining their physical significance. Through HEC-RAS simulation, we will visualize how the water surface adjusts to energy losses, why it does not run exactly parallel to the channel bed, and how we can interpret result to assess flow behavior. Whether you are a beginner or advanced user, this video will guide you a clear practical understanding of the flow behavior. So now let's solve this problem. For example, we have a prismatic channel having length 100 meter, normal depth 0.01, discharge 10 cubic meter per second, channel meaning coefficient 0.01 and the same meaning coefficient for left and right bank of the channel 0.1, slope of the bed 2%. This is basically the detail of the cross section. Here you can see it shows the coordinates and their corresponding elevation at section 11, while at section 100 this is the detail. Here what we have done, we have only added the slope which is 2% to the elevation of the cross section 1. So now open the HEC-RAS. So this is HEC-RAS. Now open new project. Here you can project and then enter. Now set units, go to option, this one, and this is SI International Metric System. So this is okay. So now click on the geometric data. Here click on the river reach. You can draw the river reach and then double click here. Here you can give the name like river 1 and this is reach 1. So now save it. So now you can see this is a river. Here if you double click on it, you can see it. You can get the detail of this particular river reach. This is the profile. So we did not enter the details, so there is no profile. So now come to the cross section. Here we have to add the detail. So let's click on this one, add a new cross section. So where we want to enter the detail, here you can see at section 11 the detail are, these are the details at section 11. Okay, so now you can put the detail. These are the detail of that particular cross section. 0, 11, 0. Here you can put 0, 5, 0, this is 15, and here you can put the corresponding elevation 11, 10, 10, and this is 11. These are the elevation detail at the corresponding points. So if you apply, then you will see the typical cross section over here. So here you can see the detail of this cross section. So this is basically 0, at point 0 the elevation is 11. So here you can see at 5 this is 5, the elevation is 10. So here you can see this is 10, and similarly at the same 5 the elevation is 7. Here you can see this is 7, and if you come over here at 10 the elevation is 0. At the 10 the elevation is 7. Here you can see, sorry. And now at the same 10 elevation is 10, this one 10 10. And now at this is 15 the elevation is 11. So now you can, these are the legends. So now put the other detail, left bank, channel and right bank. So here you can see one, this is basically cross section at 1 1 beginning. And now meaning coefficient for the channel, we have meaning coefficient, that is you can see over here 0.015, and this is left and right 0.1, this is 0.1. So you can put the detail over here. So here you can see this is 1 1 1. If there is a curve in the channel, so maybe it will be different. Main channel bank stations, this is the channel station here, this 5 and this is 10. So here 5 and 10, this will basically differentiate these banks and the channel. So now when you apply the data here, you can see the dots over here. This is because of this 5 and 10 I have put it over here, and leave this for now, this contraction coefficient. So now you can see this is the meaning coefficient for the channel, and this is the meaning coefficient for the banks. So now this cross section has been completed. Now new option, add new cross section, and this cross section will be at 100, as I have already mentioned. So so here select one. When you select one, that you can see the detail over here. When you select 100, as I did not insert the data, so the detail is missing. So now we will now copy the current section, now at 100, at 1 you see this detail. If you come to 100, you will see again the same detail. So now we will update. So we have a slope of 1%, 2% slope. So basically we will add 2 elevation to the all of the elevation at the section 1. So now add elevation 2. So you can see this elevation will be updated. Now you can see from 11 it become 13, from 12, from 10 it become 12, and from 7 it 9, and so on. So elevation has been added. Now you can see this cross section 1 and this is cross section 10. So here you can see the same detail over here of the cross sections. So the detail has been completed. Now you can close it over here. Now file, you can save the geometry. Geometry 11, or you can give any name. So now this has been saved. Now we will come to the next section, that is click the next section that is basically related to the flow. So now we will basically insert the flow details. You can close it over here. This is flow detail. So this is basically flow here. If you have one, if you have two, if you have return period, so definitely you will get here is one flow. So when you press it over 2, so you can put it over here for this particular section. 2 flow detail, that is return period, 5 return period and 10 return or whatever you have. So now as we have 1, so put it over here and then enter. Yes, we have only one flow, and the flow is given over here, that is 10 cubic meter. So you can write it over here. And now put the boundary condition at the downstream. So definitely we will use normal depth, and normal depth is over here 0.01. So put it over there and then OK, and then apply the data. You can save the flow data. Flow 11. So now close it. Now run the model. So click on this one, select subcritical and then compute. So now it running is complete now. Now you can click on the view cross section. Here you can see this is the cross section. Here this shows water from the region, you can see over here. If you click on this one, this is basically critical profile. What is this? This is basically energy line. So the energy line is above the critical line. So now based on this you can differentiate the flow, and this is basically shows the banks. Here you can see these are the banks. So this is at section 100. If you need the same detail in section 1, which we have only 2 details, so these are basically the section 2 detail. So there is the slope is basically, here you can see this. So the flow is uniform, there is no change along the distance. So you can see energy line is parallel to the critical line. This is energy line, both are parallel to each other and parallel to the bottom. So now if we change the flow condition, boundary condition, such like this 0.001, make it mild, and then OK, and then apply data. Now close it, run it again, subcritical and then compute. So now it's model running completed. So close this again, you can check the section over here. So now we have changed the normal depth. So now you can see the flow depth has been increased because the slope is mild now. You can see the critical depth and then the energy line and the critical depth. Now again you can check the 100 meters. So at 100 meters you can see this is this. So this is all about this video. In the next video I will explain the flow based on this energy line and the critical line, water surface profile. So this is all about this video.